Have you ever marveled at the vibrant colors of a butterfly's wings? These colors are so vivid and striking that they almost seem otherworldly. These colors are not from pigments. Unlike the colors we see in paints or dyes, which come from chemical pigments, butterfly wings use a different method. They are created by something much more fascinating called structural color. This phenomenon occurs at a microscopic level, where tiny structures manipulate light. Imagine light as a wave. Just like waves in the ocean, light waves can be bent, reflected, and scattered. When light hits a surface with tiny structures, it bounces off in a specific way. These interactions depend on the size and shape of the structures. This creates the colors we see. The specific arrangement of these microscopic structures determines the exact color that is produced. It's like a symphony of light and structure. Each tiny element plays its part, contributing to the overall visual masterpiece. Think of a soap bubble. The thin film of soap creates a dazzling array of colors. Its shimmering colors are due to structural color. The varying thickness of the soap film causes light to interfere in different ways. The thin film of soap interacts with light, creating those mesmerizing patterns. This is a perfect example of structural color in action. In nature, we find structural color in bird feathers, beetle shells, and even some plants. These natural examples are both beautiful and functional. These natural wonders have inspired scientists to explore new frontiers in color technology. By understanding and mimicking these natural processes, we can create new materials and applications that harness the power of structural color. Butterfly wings, especially those of the morpho butterfly, are a prime example of structural color. These butterflies are not just beautiful, they are marvels of natural engineering. Their wings have tiny scales that act like prisms, splitting and reflecting light in a way that creates vibrant colors. These scales reflect light in a way that creates their brilliant blue color, a phenomenon that has fascinated scientists for years. Scientists have been studying these structures to unlock the secrets of color-changing materials. By understanding how these natural systems work, they hope to replicate them in new technologies. Imagine a paint that changes color with the angle of light, just like a butterfly's wing. This could revolutionize everything from art to architecture. This is the promise of structural color technology. It offers a new way to create colors without using traditional pigments. Researchers are working to mimic the intricate designs found in nature. They are developing methods to reproduce these patterns on a larger scale. They are creating new materials that can reflect specific wavelengths of light, paving the way for innovative applications in various fields. Creating these color-changing materials requires working at a very small scale. This is where nanotechnology comes in. Scientists use nanotechnology to engineer materials at the atomic and molecular level. They can create tiny structures that interact with light in precise ways. Imagine building a house of cards. Now shrink that house down to the size of a virus. This gives you an idea of the scale at which nanotechnologists work. With such precision, they can control the way light interacts with materials, leading to the creation of vibrant and dynamic colors. Structural color has the potential to revolutionize many industries. This innovative technology, inspired by nature, uses microscopic structures to create vibrant colors without pigments. Imagine buildings that change color with the time of day, adapting to the environment and creating dynamic urban landscapes that are both beautiful and functional. Or cars with paint that shifts hues as you drive, providing not only aesthetic appeal but also potential safety features by making vehicles more visible in different conditions. This technology could also lead to more energy-efficient displays, reducing power consumption while offering brighter and more vivid screens for our devices, and even new forms of camouflage, which could be used in both military applications and wildlife conservation, helping species blend into their environments more effectively. Beyond these applications, structural color could change how we think about color itself, offering a sustainable and long-lasting alternative to traditional dyes and pigments. It could lead to new forms of art and design, pushing the boundaries of creativity and allowing artists to explore new dimensions of visual expression. The possibilities are as limitless as the colors in a rainbow, opening up a world of innovation and creativity that we're only beginning to explore. This is just the beginning of a colorful revolution inspired by the wings of a butterfly, showing us that the future of color is bright and full of potential.